Hello, today I will be talking about energy diagrams and what they look like for both endothermic and exothermic reactions, and what a multi-step reaction diagram looks like as well. Here we have an example of an energy diagram, and this one is endothermic. The specific question we will be working with is to sketch an energy diagram with energy on the y-axis and reaction coordinates on the x-axis for the given mechanisms. Assume that the overall reaction is exothermic and that the formation of an intermediate is endothermic. We'll have to show relative energies of reactants, products, intermediates, activated complexes, which are also known as transition states, and activation energies. The information that we need in order to do this is to know what an energy diagram is and what each of the things listed corresponds to on an energy diagram. So what is an energy diagram? An energy diagram is commonly known as a chemical reaction's energy profile or reaction coordinate diagram. It is a theoretical representation of an energetic pathway as reactants are transformed to products along a reaction coordinate, and this means that it shows the energy of a reaction as it goes from reactants to products. So here are some definitions of the things that we were asked to show. They're mostly just reviewed to make sure that we know what corresponds to what. So reactants are the substances that react in a chemical reaction and turn into other substances. They will be on the left. So here in this specific process, they're CH4, which is methane, and then the two O2s, which is molecular oxygen. So products are the substances produced in a chemical reaction, and there's CO2, which is carbon dioxide, and two H2Os, which is water. They'll be also on the same sides for energy diagrams, so the reactants will be on the left side and the products will be on the right. Reaction coordinate. What is a reaction coordinate? A reaction coordinate is a curve that follows the pathway of a reaction and shows its progress. Reaction coordinates will be curves along the x-axis, and they'll show the progress of the reaction as it goes from reactants to products. And if it has more than one step in it, it will show intermediates, and it'll be more than one curve for each. Intermediates are molecules that are formed in a step of a reaction and then are consumed in another step of the reaction. Intermediates don't show up in an overall reaction, so they'll be in the middle, but they're not reactants or products. Activated complexes are also known as transition states, and they're the states corresponding to the most energy on a reaction coordinate, so they'll have the highest amount of energy and they'll be at the peak of a curve for each step in a reaction, and they'll be shown if there's more than two steps in a reaction, then the energy diagram will show that. Endothermic reactions are processes that absorb energy. They're reactions that have a delta H, which is a change in enthalpy greater than 0. Heat is energy, and it's represented on the y-axis. And for endothermic reactions, the products will have a higher y-coordinate than the reactants because they take in heat energy. So for an endothermic reaction, the products will be at a higher energy level than the reactants. Exothermic reactions are processes that release energy, and in them, the delta H is less than 0 because heat is being released. For them, the y-coordinate of the products will be lower than the y-coordinates of the reactions because this reflects the energy lost as heat. The last thing that we need to know is the activation energy. Activation energy is also represented as capital E subscript A. The activation energy must be provided to a system with the reactants for a reaction to occur. So that's going to be the whole height of a curve, and that's just how much energy is needed for the process to really happen. Here we're shown a few examples of energy diagrams. The first example is an exothermic energy diagram, and we can tell this because the products, which are on the left, are at a lower energy level than the reactants, and here we see that the energy level is the y-axis and the reaction coordinate is the x-axis. So the reactants are on the left, and we can see that they're about at the middle for the energy level, and then we follow the curve, and the transition state is the very peak of that curve, and at the end, at the bottom, the curve ends almost at zero, and we see that the products have a lower energy, so this makes it exothermic. The next reaction has two transition states. We see this because there's two curves, so that means that this reaction has more than one step. It has two steps, and here the energy is still the y-axis, and the reaction coordinate is the x-axis, and we see that the reactants start on the left, and then they move along the curve to the first transition state, and then we go down to the intermediate before we go on to the next curve, and we reach the peak of it and reach a transition state. And then at the end of that curve, we'll have the final products, and we see that this reaction is exothermic because the products are at a lower energy level than the reactants, and it's exothermic for both the intermediate and the actual products. The last diagram also has the energy as the y coordinates, and here the x has a different name, but it's the same thing. It's just the progress of a reaction, which is the same thing as the reaction coordinate. So here we see that the products start at a relatively low energy level, and then we follow the curve up to the transition state, also known as the activated complex, and the height of that curve is the activation energy, which is the energy needed for the reaction to happen. And then at the end of the curve are the products. So that's the final state, but we see that they end at a higher energy level than the reactants. This means that this reaction took in energy to make the products, since the products are at higher potential energy than the reactants here. So now that we've gone over that, we've reviewed some and seen some examples of other energy diagrams, we can answer the question, which is to sketch an energy diagram with energy on the y-axis and reaction coordinates on the x-axis for a given mechanism. We assume that the overall reaction is exothermic and that the formation of an intermediate is endothermic. We will show relative energies of reactants, products, intermediates, activated complexes, which are also known as transition states, and activation energies. Here's the sketched energy diagram. So here we have the energy on the y-axis, the reaction coordinate on the x-axis. We have reactants to the left. We have the intermediate, which is shown to be, the first step is shown to be endothermic because it has the intermediates at a higher energy level than the reactants. The transition states are there. There's relative activation energies shown, and then there's the products.